Hey, it's Medusa, and today we are hopping into KryptSec to tackle another lab called CSRF Password Reset. But before we move into that, I wanted to show you something. If you go to the CDF page, cdf.cryptsec.com, you will see another feature that was added recently. It's called the archives. So basically, there are labs in the archives, or you can call it challenges in the archives, where you don't get points. So it's not connected to leaderboard and there is no timer, as you can see over here. These are some 6 operations from the past op blackout campaigns, archived for replay, no timer, no leaderboard, just a lab if you want to practice. And that's what we're looking at. But if you go back and if you want to participate in any of these labs, these are actually connected to points. So let's say if you solve this lab, you will get 100 points for this. So the labs that are archived, it won't get you points, but it's good for practice if you want to. Anyways, so the one we are looking at today is CSRF Password Reset, so let's activate it real quick. All right, so before we get into the lab, let me tell you why this one actually matters. CSRF, that stands for Cross-Site Request Forgery. It sounds technical, but the attack itself is almost embarrassingly simple. The idea is this. You're logged into a website and an attacker tricks you into making requests you never intended to make without you even knowing it happened. Just one click on the wrong link and that's it. So in this lab, we are targeting a password reset flow. And the scary part, this isn't some obscure edge case. Password reset endpoints are everywhere in almost all the applications. And when they're not protected against CSRF, an attacker can force a victim to reset their own password to something that an attacker controls. And this is a real attack pattern. It's been found in production apps, it's been exploited in the wild, and it's exactly the kind of thing that slips through code review because it looks fine on the surface. Okay, deploying. Let's go back to the lab. And over here, again, we have some details. Let's just copy this lab URL. Okay, let's open this lab URL. And yeah, let's go to login. So we should have credentials. Yeah, so we have login as Lini and password ghost404. So let's type in real quick. Okay, so we are logged into the Merchant's Tech Hub. This is pretty interesting, but before I move on further in this lab, I want to give a quick summary of CSRF vulnerabilities. An attacker can craft an exploit and send it to you through a link, and by clicking on that link, your password will change like automatically and you won't even realize it. That's literally insane, and that's exactly what we are going to do here. And not just like password, there are multiple things you can do, like adding something to someone's card, changing email, password again, or deleting something. Any action that doesn't have a proper validation can be exploited through CSRF attack. You'll get more details as you watch in this video. So over here we have actions like check inbox, browse products, and change password. And obviously the interesting one in this case is change password. So let's click on that. And we have new password and confirm password field. But before we type in the password, I want to open Networks tab because I'm interested in looking at what request passes through in the backend when I click on update password, because this is important for the CSRF exploit. Okay, so currently we don't see any request, but let's type in a password real quick. I'm going to use a simple password. Let's say hacked 101. Update password. Not now. Interesting. We don't see any request here, but it says password updated successfully. Let's go to all. Okay. We see a post request here. It's reset password, and let's see what parameters we have in the request. So we have new password and confirm password. And in the response, we have HTML. And actually, that's the reason why we didn't see it in XHR, because usually you see request with JSON body in XHR, not a request with HTML form URL encoded content type. So keep that in mind. Well, the important thing to know here is In this request, actually, you notice that there is no CSRF validation. I mean, usually to protect CSRF attacks, you provide a CSRF token. So this CSRF token is random and it makes sure that not anyone else can replicate your request and make those requests for you or on behalf of you. So that's the job of CSRF token, but we don't see any CSRF token here. If you go back to headers, we can see, okay, we have cookie and okay, that's all we have. Okay, so that's all the application is using. There is no bearer token or anything like that. There's just cookie, and there's also no CSRF token in the form data. Now, this is red flag actually. Whenever you are looking for CSRF vulnerabilities, there are like 3 conditions. So the first condition is when you look at the content type, it should be application form URL encoded. If that's the case, if that's true, okay, one condition is done. Second condition is there is cookies in the browser like this. I mean, there is no other type of cookie like authorization bearer tokens, and there's only just cookie like this. Okay, that's another condition that is met. Now, the last condition is the parameters that are going in the post request shouldn't be random. For example, new password and confirm password values. It's not random. Anyone can set it. I can guess, okay, let's think of a password for another user and I can set it. But if there's a CSRF token here with a random value, I cannot think that. I mean, that value is set by the server, not by me, and I cannot guess that. And if I cannot guess that, I cannot perform this exploit. If it's still not making sense, then it will make sense when I start writing the exploit. So, okay, let me open my terminal first. I mean, if you're someone who does understand what CSRF actually is and just wanna like understand how to solve this challenge, then you can skip that part too if you like. But yeah, I like to explain everything. Well, I'm in my Cloud Code and I can use it to write the exploit. But before we do that, let's go to the exploit server. This is basically the server where we are going to host our exploit. So whenever you're performing CSRF attacks, you're supposed to host your exploit and then you're supposed to give that a link to the victim user. Well, so that's what we're going to do here. Let's open the exploit server. Okay, so now we are in the exploit server and it says exploit server active and it is CSRF exploit crafting interface. Now there's some few attack parameters that you need to know. First we have is lab ID, new password, and confirm password. So we're gonna keep this one as it is. No need to change that, but we can change if you like. But yeah, over here we have the bodies. So this is where we are going to type our HTML exploit. Okay, so first let's fill in these values, lab ID. Let's go back to the lab. And let's copy it. Let's paste. And just remove this part, labs.kryptsec.com and HTTPS as well. Okay, so this is what you need actually. And you will see how the target URL will look like, okay? So this is how the target URL looks like. And now we are going to paste in the exploit. So let's utilize AI for this tedious task. Let's go back and we are going to copy this. Let's open my notepad. Okay, I'm going to paste that endpoint here and in the request, I'm going to click on raw, copy that value. Okay, that's all we need to copy this. And now we'll go to Cloud Code. Hi, I'm doing a pen test and I need your help with writing CSRF POC. This is the URL and parameters. Don't change the password value. Write a simple exploit. Okay. That's it. It's gonna do the thing. Since we're not changing the password, the password we provided in the prompt is hacked 101. So we have to change that here as well. Cool. I forgot to paste. Okay, let's just paste. Okay, we got the CSRF Password Reset POC.html file. I'm just gonna copy it. No need to create files for now. And let's just paste it here. Okay, so what this exploit is doing, let me explain. First, we have basic HTML syntax, HTML body, and then we have form ID CSRF with action. So we are trying to perform an action at this endpoint, password reset, because we want to change the password of victim user. Now it's a post method, so you have to provide post. And then we are providing input type because there are two parameters that we need to provide, and we are keeping it hidden because we don't want it to be visible in the UI. So the value will be changed to hacked 101. It means that whatever password victim has currently right now, it will be changed to hacked 101 once they click on it. Okay, so the next important point is script document.getElement by id csrf.submit. What this is doing is basically it's selecting an element with id csrf, which is this form, and then it's going to auto submit it. It will auto submit the values and it will basically make a request on the victim user behalf. So now once this is done, we're gonna click on store. And it says exploit stored. You can also view the access logs by looking over here, and you can see that exploit is stored. Now let's deliver this to victim. And it says exploit delivered to victim inbox. The admin will check emails within 7 seconds. So let's wait like 10 seconds. And yeah, I do want to mention that the victim user in this case is merchant. So we will keep this username and then we will type the new password that we just changed to see if we can log in or not. Okay, so I think the victim or the admin must have checked the inbox by now. Let's go to the merchant page and let's click on login. Let's type in the username, merchant, and the password is hacked 101. Let's log in. Not now. Okay, we are in the admin's account. That's crazy. And we can also see the email, role admin, how long they've been members since. That's crazy. And we can also see some of their personal account notes. Okay, and let's go to my account or admin panel. I think admin panel is more interesting right now because we are already in my account. And yeah, we got the flag. Great. So we can submit the flag here. And yeah, that's correct. Okay, so that's how you exploit CSRF. Okay, so now we just exploited this vulnerability, but the question also arises that how we can prevent these type of vulnerabilities. The most adopted way to prevent CSRF vulnerability is using CSRF token. CSRF token are random values, and these random values are set by the server, so it cannot be guessed. And since it cannot be guessed, an attacker cannot create request. And that's why I waited through the end of the video to tell you about the prevention methods, because first you understood how it's exploited. To exploit this, you have to craft an HTML body and everything, right? And in the body, we provided path, the password reset path, and we didn't have to provide cookie because when you send a request, the browser automatically assigns the cookie to the request. So these are the things we could guess, but what an attacker cannot guess is a CSRF token. And that's why if CSRF token is present and it's getting validated properly on the server side, we could never exploit CSRF vulnerability in that cases. So I hope you understood the steps and it makes much more sense now. Let me know your thoughts in the comment section. Don't forget to subscribe to the channel and I'll see you in the next one.